In the last video, we finished our preparation work by creating our item classes, so now we can work on the core of our system, which is the inventory actor. To begin, we'll have to create another structure, so go inside of your structures folder and right click to create a new one. Call that one S_inventory_slot. Open it up. Inside here we will store all the variables that we want to have for all of our slots. So the assigned item class, which is of the type BP master item class. So it's one of our item classes that we created in the last video, and we want to have another variable which is the amount of items on this slot. For example, you could have 50 health potions on one slot and its type will be an integer. Save it and close it, and now you can go back to the blueprints folder and right click somewhere in here to create a new blueprint class. Choose the parent class actor and call it something like BP_inventory. In here we'll hop over to the event graph and create some variables. The first one will be amount of slots, and its type will be an integer. The next one will be our maximum stack size, or just call it max stack size. Then we'll have to create another variable which is a reference to our top-down character, so just call that top-down char ref, and change its type to top-down character reference. Also make sure that it is exposed on spawn and editable, as well as our amount of slots. Compile that and save. And we have to create an array with all of our slots, so create another variable and call that one slots. Change its variable type to the structure we just created, so S_inventory_slot, and hit the make array button. Compile and save. So right now our amount of slots variable is doing nothing, but we'll change that now. So on event begin play, you want to grab the slots and drag it in here and search for resize. Connect the resize node with the event begin play, and for the integer here you will have to drag in our amount of slots. So that way we will have as many slots in our inventory as our amount of slots variable says. Compile that and save, and now we'll have to work on some functions for our inventory. Hit the plus icon to create a first function and call this one is SlotEmpty ? And for this we want to have an input which is the index of our slot, and its type is integer, and we want to have an output which is a boolean, it's empty ? Also check the pure box over here. By the way, if you don't know whether your function is a pure or impure function, just ask yourself, does this function change anything inside of my class, or does it just return something? If it only returns something, you can check the pure checkbox over here. So now you want to grab your slots array, drag off of it and search for get. For the index, grab the index from our input node, and then you'll have to break the structure here and create a check whether our item class is valid. If it is valid, there is an item assigned to our slot, so it's not empty. Search for not and plug that into our empty output. And that's it for our SlotEmpty function. Compile that one and save, and make another function called GetItemInfo info add index. Make a new input, which will be the index again, and create 3 outputs. So the first one will be empty slot question mark. The second one will be our item info, and the third one will be the amount of items on the slot. For the item info, select the variable type here and change it to our s_iteminfo, and the empty slot should be a boolean. Now drag in the slots array again and search for get, plug in the index, break the struct, and perform an isValid check again. If it is a valid class, we will drag off of the item class and search for get class defaults. So you get the default values of every variable inside of this class, and this one will be the item info. It will not be empty since our class is valid. It will not be empty, and the amount comes from the inventory slot here. Also make sure to connect the true to the return node, and right click somewhere here and search for another return node. So if our class is not valid, it will be an empty slot, and you can just leave the item info and amount as it is. Also make sure that this one is also a pure function. Compile and save that one. The third function will be SearchEmptySlot. And what it basically does is just returns the index of the first free slot that we find inside of our slot array, so we can add the item there when we'll create our AddItem function later on. For this function, create a new output, which will be a boolean, and call this one success, which will just return whether we found an index or not, and create another one, and that will be the actual index that we found the free slot on. So now what you want to do is grab your slots array and search for each loop with break. Connect the execute. Drag out the array element and break the inventory slot again. And we want to check whether our item class is valid. If it is valid, we will do nothing, since it won't be an empty slot then. But if it's false, we will create a new local variable, which we'll call local bool. Change its type to bool and don't make it an array. We will set this local bool to true, so we found something. And we'll create another local variable, call that local index. Make it an integer and set this one to the array index you found. And make sure that it's connected to the false and not the true of the branch. So just alt click on the true to disconnect the wire, drag them down here and connect them to the false. And of the local index, you want to drag it all over to the right of the screen and plug it into the break. So our loop will stop if we found something. When it's completed, we want to return, and the success will be our local boolean, and the index will be our local index. Compile and save that again. Before we can actually create the functionality to add items, we just need another helper function, which is called SearchFreezeStack, which just means that for all of our stackable items, we won't search for an empty slot, but we rather want to search for a free stack that we can add the item to. And it needs an input, which is the item class. So what item do we want to add? And its type will be BP master item class again. Also create some outputs, again a boolean for success. Did we find anything? And if so, we'll have to create another output for the index and change its type to an integer again. So we'll do the same thing again. We grab our slots and type in for each loop with break, connect it to the execute. We'll break our struct here again, and first we want to see if our class is valid. Search your branch again, and if it is valid, we want to check whether its class is the same one as the one we're searching for. So grab another branch, connect the true of it to the other branch. Its condition will be whether our item class double equals the class we're searching for, and the amount of items on the stack should be less than our maximum stack size, which means that our stack is not full. Connect the end to the condition. Also, we have to create two local variables as we did in our SearchEmptySlot function, so quickly do that. One is our local bool. Its type will be boolean, and the other one will be the local index. Just as we did before, it's an integer. So if our class is the same as the one we're searching for and the stack isn't full, we set the bool to true and the local index to our index from the loop, and we'll also break out of this loop again, move the return node to the completed, grab our local bool and our local index and plug them in for success and the output index. Compile and save. So that's basically all of our helper functions we will need for the next function, which is actually to add an item. So hit the plus sign for the function once more and type in add item. Here we will need two inputs. First of all, the item class, which is again a BP master item class, and the amount of items we want to add, which is an integer. Compile that one and save. First we want to check whether the item that we're trying to add is stackable, because there's different functionality based on whether it's stackable or not. So drag out the item class, break this one, get the class defaults, and the item info you'll have to break. Hit that little arrow icon here so you get the full structure, and off of the can be used you can type an if to quickly create a branch, connect the execution of our function to the branch, and I think we'll do the false execution first because it's much simpler. Actually, you don't want to check whether the item can be used, but whether it can be stacked. Sorry for that one. And of the false, we want to search for an empty slot, and if there is one, we will get our slots array and set array element on the index we just found to the item we want to add and an amount of 1 because it can't be stacked. So to do that, you will have to right click on the item structure, the inventory slot structure here, and split that struct bin. The item class will be the class from here. So before we go into the branch, let's promote those to local variables. That is our local class. And the amount we'll promote to a local variable as well. Call that one local amount. Also, just for better readability, create another local variable and call that found index. And if we found an empty slot, set the found index to the return value of our index here. You can then change the index instead of the set array element node to our found index. And the item class will be our local class. And the amount will be 1, since this item cannot be stacked. Connect those two and search for the return node. Sorry, I forgot something. You have to create another output first, which is again whether it was successful or not. And for the return node here, you can check the successful. But before you return, we'll have to check whether our amount is greater than 1. And if it is, we will call the same function that we're inside of once again. So call AddItem with our local class as the item class. And the amount will be our local amount minus 1. So what this is doing is, for example, if we want to add 5 maps to our inventory, it will not just add 5 maps, but it will add 1 map 5 times. And after the add item, you will go to the return node and plug in success. If our local amount is not greater than 1, you will just go to the return node as well and check the success. And before here on the branch, whether we found an empty slot or not, if we didn't find an empty slot, go to the return node and check this and don't check the success because we failed. Compile and save. And let's do the execution path for our true. So if our item can be stacked, we will search for a free stack of our item. So item class will be our local class. And if we found something, or let's do the if we didn't find anything first. So off of the false, we will then search for an empty slot. And of the success, type in if once again. And of the false, you can go to the return node. So we didn't find a free stack and we didn't find an empty slot. So we completely failed trying to add our item. But if we did find an empty slot, we will set the found index to our index again and drag in our slots array, set the array element, add our found index, Make sure to split the struct bin of the item as well to our local class. And for the amount, we will actually have to do something else. Just drag them a bit to the right of the screen. And we'll have to check something else, because if our local amount is greater than our maximum stack size, then we'll have to set the item amount here to our maximum stack size. But there will be a rest of items that we still have to add, so for that amount you can drag in our local amount, type in minus the maximum stack size, so this is our rest, and with that rest we will call our AddItem function again, plug the rest in for the amount, and for our item class the local class, and at the end you'll need a return node. Check the success. So now for the false execution, if our local amount is equal to our max size or less than our max stack size, we just want to grab our slots array again, set the array element at our found index, and the item will be our local class. For the amount, we set our local amount and return. Also make sure to check the success again. Now we have to go all the way back to our branch here where we've searched for a free stack. So if we found a free stack, let's promote the index to the found index. And we'll have to check something again. So we'll get our slots and get from it at the found index, so the stack we just found, break the struct, and we'll need the amount here. So we'll have to check whether our maximum stack size, no, we'll have to check whether the amount plus our local amount is greater than our maximum stack size. Again, let's do the false first. If it is not greater, if it's less or equal, we just want to set an array element again, index, drag those bits to the bottom of the screen so there's a bit more room. The index will be our found index again. Make sure to split the struct bin as well. Add our local class, and for the amount we'll have to get the amount of our already existing stack and add the local amount to it. So just grab this one, plug it in for the amount and return. Hit the success again, and of the true we want to grab our slots as well, set the array element, add our found index to our local class, and the item amount will be our maximum stack size because this stack will be full then. But after it we have to calculate the rest again, so we'll, before all of this, we will set our local amount, drag those a bit to the right here, we will set our local amount, and that will be our local amount here, a local amount plus the amount on our slot minus our maximum stack size. That will be the rest we'll have to add. So after we set the array element, call our function AddItem again. Amount will be our local amount, and the item class will be our local class. Connect the set array element and add item, and finally add the last return out and check the success. Compile and save. So that's it for this tutorial. In the next one we will create our pickup actors and actually debug our inventory functionality. See you then.